Hi everyone. Today we're going to study derivative, the slope of the tangent line. Suppose we have a function f which has the following curve. Then let us pick 2 points of the curve. Let us name the coordinates of the 2 points, namely x, f of x for the first point, and the second point is x plus h, f of x plus h. Take note that the distance between the x coordinates of the 2 points is h. Now, let us draw a line connecting the 2 points. We call this line the secant line. With respect to slope of secant line, we will write m equals f of x plus h minus f of x all over x plus h minus x. We can see here that our denominator can be simplified into h. So we write it like this. Now, suppose we continue to compute the slopes of this line for smaller and smaller values of h, as we see that h goes to 0. So the line will be changed and it will look like this. In this case, the 2 points now coincide. And the previous secant line, we will now call it as tangent line. Now, with regard to the slope of tangent line, we will now write the limit of f of x plus h minus f of x all over h as h approaches 0. This time, let us have a formal definition. The derivative of f with respect to x, denoted by f prime of x, is defined to be, this is the formula, f prime of x equals the limit of f of x plus h minus f of x all over h as h approaches 0, provided the limit exists. Let us see this example. Find the derivative of f of x equals 3x minus x squared using the definition. For our solution, let us write our formula here. And let us have the step 1, and that is to evaluate the function f of x plus h. It means, considering the given function here, let us substitute x plus h to all the x that we will see in the function. So we have now f of x plus h equals, the 3x here becomes 3 times the quantity x plus h minus the x squared now becomes the square of the quantity x plus h. Let us simplify, and we have now 3x plus 3h minus, let us expand the square of x plus h into x squared plus 2hx plus h squared. Simplifying further by removing the grouping symbol, considering the negative sign here, And the final answer for step 1 is 3x plus 3h minus x squared minus 2hx minus h squared. And then step 2, solve for the derivative. Let us now substitute the corresponding value to our formula here. So we have now f prime of x equals the limit of this function f of x plus h is now the value that we solved from step 1. So we have this big polynomial we will write here minus the f of x is the given function here. So we have 3x minus x squared all over h as h approaches 0. Please observe in our numerator that we can simplify by removing the grouping symbol, and then we can see some terms that we can cancel. The 3x here can be cancelled with the 3x there. This negative x squared here can be cancelled with the negative x squared here. Now let us rewrite our limit in simplified form. So we have f prime of x equals the limit of 3h minus 2hx minus h squared all over h as h approaches 0. Observe again that in our numerator there is a common factor which is h. Let us factor it out. So we have now h times the quantity 3 minus 2x minus h all over h. So we can cancel this h in the denominator and that common factor. Simplifying further, we have the limit of the quantity 3 minus 2x minus h as h approaches 0. Let us now simplify this limit by substituting 0 to that value of h. So we have 3 minus 2x minus 0. And the final answer is 3 minus 2x. This is the derivative that we are looking for. This is the final answer. Hi everyone. Today we're going to study derivative of a function, and we will see some sample problems. Let us first state the definition of derivative. The derivative of f with respect to x, denoted by f prime of x, is defined to be f prime of x equals the limit of f of x plus h minus f of x all over h as h approaches 0, provided the limit exists. Let us see this example 1. Find the derivative of f of x equals 5x minus 2 using the definition. Let us write our formula for derivative here. And for our step 1, let us evaluate f of x plus h. Considering our function here, we're going to change every x by x plus h. So we have now the f of x plus h equals 5 times the quantity x plus h minus 2. Simplifying this, we have now 5x plus 5h minus 2. For step 2, let us now evaluate the limit formula of derivative. So we write here f prime of x equals the limit of 5x plus 5h minus 2. This comes from our step 1, and this is our f of x plus h. Then minus f of x. This is the given function, the 5x minus 2. So we write it here. All over h, as h approaches 0. Let us simplify by removing the grouping symbol of our numerator. So we have now 5x plus 5h minus 2 minus 5x plus 2. We can see that some terms in our numerator can be simplified or combined together. Look at this 5x. We have negative 5x here, so they zero out each other. The negative 2 and the plus 2 will be 0 also. Writing again in simplified form, our function now becomes 5h over h. The h and the h can also cancel out. Our function now is simplified into a constant 5. So the limit of 5 as h approaches 0, and we have our answer, which is 5. This is our final answer. This is the derivative of our function. Let us see this example 2. Find the derivative of f of x equals the fraction x over x minus 1 using the definition. For our solution, we write again the limit formula of derivative, and then our step 1 is to evaluate f of x plus h. This is equal to x plus h all over the quantity x plus h minus 1. We can simplify our fraction here by removing the grouping symbol. So we have now our new fraction here. For step 2, let us now evaluate the limit formula of derivative. So we write here f prime of x equals the limit of this f of x plus h, and we copy this fraction in here, minus the f of x is our given function, so we copy it in here, all over h, as h approaches 0. We can see that we have a complex fraction here. Let us simplify our numerator by multiplying this fraction first diagonally down here, and then minus this denominator we multiply by our numerator of the second fraction all over the product of the two denominators. So it will be like this. While the h in here, we will flip it up and we write here times 1 over h. Now, let us simplify our numerator by multiplying the corresponding factors. So we have here x squared minus x plus hx minus h minus the quantity x squared plus hx minus x. Now let us remove the grouping symbol and let us see if we can combine some terms. So it will be like this now. Please observe that this x squared has a counterpart of negative x squared here. It becomes 0. We have negative x and positive x. It will be 0 also. The positive hx, and we have this negative hx. If we remove those terms, we can simplify our fraction here into simply negative h. This negative h in our numerator now and the h in the denominator can cancel each other. So writing again our fraction, the simplified form into negative 1 all over this denominator. Now let us evaluate the limit as h approaches 0. It means we are now to substitute 0 to this value of h. Here we go. Simplifying further, we can now remove the 0 and we can see that this is now negative 1 all over x minus 1 times x minus 1. We can put the factors together using exponent. So our final answer is negative 1 over the square of x minus 1. This is the derivative of our function here. Let us see example 3. Find the derivative of f of x equals the square root of x using the definition. We have here again our formula, and step 1 is to evaluate f of x plus h. So we have here f of x plus h equals the square root of x plus h. Step 2, to evaluate the limit formula of derivative. So we have now f prime of x equals the limit of the square root of the quantity x plus h minus the square root of x all over h as h approaches 0. Let us now simplify our fraction here. Please remember our special product formula that a minus b times a plus b equals a square minus b square. We said that the factors here are conjugate of one another. So to simplify our fraction here, we want to remove the radical. So we're going to multiply this fraction by another fraction whose numerator and denominator is the conjugate of our numerator here. So we have to multiply this by square root of x plus h plus the square root of x. Take note, this is negative, so we write here positive. So the numerator here is the same with our denominator. When we multiply now these two big fractions, in the numerator, we're going to apply our special product formula. While in the denominator, we will simply put together the two denominators. So it will be like this. The limit of the square of the quantity square root of x plus h minus the square of the square root of x all over the denominator is simply putting together the h and these big radicals. Now let us cancel out the square and the radical sign, and let us write again the fraction here. So we have now the limit of x plus h minus x all over our same denominator. We can see here that in the numerator, the x minus x becomes 0. So only the h remains in our numerator. Please observe also that there is an h in our denominator. So we can cancel the h and the h respectively. Simplifying further, we can now write the limit of 1 all over the square root of the quantity x plus h plus the square root of x. Now, let us evaluate the limit as h approaches 0. Let us substitute the value 0 to our h here. So we have now 1 over the square root of x plus 0 plus the square root of x, that we can show that this is equal to 1 over the square root of x plus square root of x. We can now put together the square root of x into 1 over 2 square root of x. This is our final answer. This is the derivative of our function here. Hi everyone. Today we're going to study derivative notations. Given the function y equals f of x, the following notations are used to denote its derivative. This is the first notation, and we read this as f prime of x. The second notation is here, and we read this as y prime. This is the third notation, and we read this as dy over dx. This is the fourth notation, and this is read as d over dx of f of x. Now, the derivative of f at a specific point x equals a is dy over dx with the subscript x equals a. And we further evaluate this by f prime of a. Hi everyone. Today we're going to study basic rules of derivative. Let's have the first rule. This is about derivative of a constant. If k is a constant, then d over dx of k equals 0. Let us see some examples. This is example 1. Y equals 5. So we have y prime equals 0. Second example, y equals negative 10. This is another constant, so we say that dy over dx equals 0. In here, we used another notation of derivative. Example 3, f of x equals pi. This pi is considered a constant, so we say that f prime of x equals 0. These are the answers for these examples. Rule number 2. This is derivative of a power function. We have d over dx of x raised to n, and this is equal to n times x raised to the power n minus 1, provided that n is not equal to 0. Let us see some examples. This is example 1. Y equals x cubed. So the derivative is y prime equals The power 3 here comes down as coefficient, then multiplied by x, and this x is now raised to the power 3 minus 1. Simplifying further, the power 3 minus 1 becomes 2. So the derivative here is y prime equals 3x squared. Example 2, y equals 1 over x raised to 7. Let us show that this fraction has a term with negative exponent. So we have now x raised to negative 7. Let us now apply the rule of derivative. So our y prime here equals negative 7. That is the power that will come down here as coefficient times x raised to negative 7 minus 1. So in the exponent, the negative 7 minus 1 becomes negative 8. Putting this negative exponent into positive exponent, so we have our final answer as y prime equals negative 7 over x raised to 8. Example 3, y equals square root of x. Let us rewrite this function into a fractional exponent. So we have x raised to 1/2. And then let us apply the rule of the power function. So the y prime equals 1/2 times x raised to 1/2 minus 1. In our exponent, this 1/2 minus 1 becomes negative 1/2. And then let us rationalize the negative exponent. It becomes 1 all over 2 times x raised to positive 1/2. Let us return the fractional exponent into radical form. So we have our answer to be 1 over 2 times the square root of x. These are the answers for the given examples. Rule number 3. Multiplication of a constant by a function. If k is a constant, then d over dx of k times f. This f is a function. So this is equal to k times the derivative of the function. Example 1, we have f of x equals 2x raised to 5. So the derivative here is 2 times the derivative of this x raised to 5. And that is equal to 5x raised to 4. Then we will multiply the constant 2 with the coefficient 5. So the final answer is 10x raised to 4. Example 2, y equals 5x raised to negative 3. This is equal to dy over dx equals 5 times negative 3 times x raised to negative 4. We multiply 5 times negative 3, and our final answer is negative 15x raised to negative 4. These are the answers for the given examples. Rule number 4 is about addition rule. So we have d over dx of the two functions f plus g. So we have here the derivative of f plus the derivative of g. Let's see this example 1. Y equals 3x raised to 5 minus 2x cubed. So we're going to take the derivative of each of the function, just like this. So we have y prime equals the derivative of 3x raised to 5 minus the derivative of 2x cubed. So we have here y prime equals 15x raised to 4 minus 6x squared. Example 2, y equals 10x plus 7. Again, we're going to take the derivative of 10x plus derivative of 7. For the derivative of 10x, we have 10 times 1 times x raised to the power 1 minus 1 plus the derivative of 7, which is a constant, is 0. Simplifying further, we have now 10 times x raised to 0. This x raised to 0 is simply 1. So 10 times 1 is equal to 10. These are the answers for the given examples. Hi everyone. Today we're going to study higher derivative. Suppose that you have a function, say f of x. Then the derivative would be f prime of x. We can consider f prime of x as a new function and find its derivative also. That is finding d over dx of f prime of x. This symbol here can be simplified into this symbol, and we read this as f double prime of x. And this is now considered to be the second derivative. We can show also that the second derivative is d over dx of d over dx of f of x. And simplifying this, we may show that d square over dx square of f of x. Or if the function is given as y, this is one of the most popular notation for second derivative, and this is d square y all over dx square. Using the second derivative of f, we can find the third derivative, the fourth derivative, and so on. Successive derivatives can be denoted as follows. Given the function f of x, f prime of x equals d over dx of f of x. This is the first derivative. F double prime of x is equal to d over dx of d over dx of f of x. Simplifying this, we can write d square all over dx square of f of x. And this notation is for the second derivative. We have now f triple prime of x, and this is equal to the derivative of the second derivative. So we see here we have d over dx of d square over dx square of f of x. We simplify this into d cubed all over dx cubed of f of x. This is the third derivative. In general, we write f raised to a power n inside a parenthesis of x is equal to d with power n all over dx raised to power n of f of x. And this is the nth derivative. Let us see this example 1. Find y triple prime of y equals 2x raised to 4 minus 3x plus 7. The y triple prime here means the third derivative. For our solution, let us begin with the first derivative. So y prime equals this 4 multiplied by 2 becomes 8 multiplied by x with the power 4 minus 1. So we see here power 3. So 8x cubed minus the derivative of 3x is here 3. So minus 3 plus derivative of the constant 7 is 0. So we will not write anymore. Therefore, the first derivative is equal to 8x cubed minus 3. Next, for the second derivative, that is y double prime equals this 3 multiplied by 8 becomes 24 times x raised to the power 3 minus 1. So we see here 2. So y double prime is equal to 24x squared. The derivative of the constant is 0. So we will not write anymore. For the third derivative, that is the y triple prime is equal to this power 2 multiplied by 24, it becomes 48 times x raised to the power 2 minus 1. So we simply put here x. So y triple prime is equal to 48x. This is our final answer. Let us see example 2. Find d square y over dx squared. So this is about second derivative of the function y equals x raised to 5 at the point x equals 2. Let's begin with finding the first derivative. So we have dy over dx equals the power 5 comes down here as coefficient. So we have here 5x raised to the power 5 minus 1, which is 4. So the first derivative is equal to 5x raised to 4. For the second derivative, we will have now this symbol. So we have 4 times 5 is equal to 20 times x raised to the power 4 minus 1. So we have here 3. So the second derivative is 20x cubed. For our problem here, we can write this in symbol as d squared over dx squared of the function x raised to 5. And we put a line here, and the subscript is that x equals 2. This is about the second derivative, and we are going to evaluate it when x is equal to 2. So this is equal to the second derivative value, 20x cubed. Now, let us substitute the value of x is equal to 2. So we have 20 times 2 raised to 3. And this 2 cubed will give us 8. And 8 times 20 is 160. This is our final answer. Hi everyone. Today we're going to study equations of tangent line and normal line. Given the function y equals f of x, and this is the curve. Now we have a tangent line that intersects the curve at the point x sub 1, y sub 1. The derivative of the function at a specific point x sub 1, y sub 1 is the slope of the tangent line to the curve at that point, which was denoted by m. It means in symbol we write m equals f prime of x at the point x sub 1, y sub 1. Therefore, for this tangent line, the equation is y minus y sub 1 equals m times the quantity x minus x sub 1. Moreover, the slope of the perpendicular line, this is the line, and we call this normal line, to the curve is negative 1 over m, where m is the slope of the tangent line at the point x sub 1, y sub 1. In other words, the slope of the normal line is the negative reciprocal of the slope of the tangent line. And the equation of the normal line is this: y minus y sub 1 equals negative 1 over m times the quantity x minus x sub 1. Let us see this example. Find the equations of the tangent line and normal line to the curve y equals 4 minus x squared at the point negative 1, 3. For our solution, the step 1 is find the slope m. So we write m equals f prime of x at the point x sub 1, y sub 1. So first, we're going to take the derivative of the curve. So we write here y prime is equal to the derivative of the constant 4 is 0, so we will not write anymore. The derivative of negative x squared is negative 2x. Next, let us substitute the value negative 1 to the x. And this negative 1 is the x coordinate of the given point. So we write m equals f prime of x at the point x sub 1, y sub 1 is equal to this negative 2x. So we write negative 2 times the x, now substituted by negative 1. So negative 2 times negative 1 is positive 2. This is the slope of the curve at the given point. This is also the slope of the tangent line at the given point. So for step 2, let us now find the equation of tangent line. Our standard form is y minus y sub 1 equals m times the quantity x minus x sub 1. Substituting the corresponding values, we have now y minus 3 is equal to, the m here becomes 2, times the quantity x minus our x sub 1 is the negative 1. Simplifying the right side, the negative times negative becomes positive. So we have positive 1 here. Simplifying again the right side, we multiply the number 2 to the x and to the 1 respectively. So we have now 2x plus 2 in the right side. Now, this negative 3 here, let us transpose to the right. From negative, it becomes positive. And then, let us combine this positive 2 and the positive 3. So we have our final answer to be y equals 2x plus 5. This is the equation of the tangent line. Now for step 3, let us find the equation of normal line. So this is our standard form, and on this part, we are going to write the negative reciprocal of the slope here. Substituting the corresponding values, we have now y minus y sub 1 becomes 3 equals, the slope here now becomes negative 1 over 2 times the quantity x minus negative 1. Simplifying further, let us cross multiply the denominator 2 to the left side. So we have now 2 times the quantity y minus 3 equals negative 1 times the quantity x plus 1. Simplifying both sides, we have now 2y minus 6 equals negative x minus 1. Since we have here a negative x, let us transpose all terms of the right side going to the left. Of course, we know that the signs must be changed respectively. So we have now x plus 2y minus 6 plus 1 equals 0. Let us combine this negative 6 plus 1, so we have negative 5. So we have now our final answer for the equation of normal line. X plus 2y minus 5 equals 0. These are the answers for the tangent line and the normal line. I hope you learned something from this video. See you again next time.